Right. Hello. Welcome to the Megaport Introducing Multi-Cloud Connectivity presentation. I appreciate all of you taking the time to attend. And this is a quick soundbite. So any questions we will likely answer via email. This session would be around 20 to 30 minutes long. So let's move on and look at the agenda. So today we're going to examine the different cloud connectivity models. These are the private connectivity models into AWS, Microsoft Azure, Google Cloud Platform, as well as a foreword of cloud industry trends. So why are we interested in cloud connectivity? Well, Gartner forecasts by 2025, cloud will serve as a foundation for most medium to large companies' digital innovation and growth strategy. Not just technological innovation, but also business innovation. Cloud services will make IT capabilities and next generation technologies available to everyone. These include user interfaces, real-time situation awareness, decision automation, and artificial intelligence. Organizations will also benefit from the rich ecosystem of tools being developed and organizations like Megaport provide unique and easy to use solutions to take advantage of hyperscaler cloud provider services and applications. Cloud services will and do play a pivotal role in how organizations handle their business to business and business to consumer interactions. As such, cloud provides opportunities for companies to differentiate their services and drive new business models. Applications themselves are undergoing major transition as well, experiencing an unprecedented pace of change, enabling them to be cloud friendly. So there's no business strategy without a cloud strategy. So a definite set of context for around the connectivity models that Megaport can offer into the cloud service providers. So let's just look at the general networking terms in AWS, Azure, and Google Cloud. So we are all familiar with these as we move forward. So what we have here is a very straightforward table showing us the three clouds. So we've got AWS, Azure, and Google Cloud. To make sure we've got these, got the terms, so everybody's has the same understanding for the rest of the call. So for AWS, the private connectivity model is Direct Connect. For Azure, that's Express Route. And for Google Cloud, it's Cloud Interconnect. There are various options under each of these services, and we're going to cover some of those as we go through the rest of the training. So the logical data center is primarily where customers' workloads reside and what we want to get to. And these are often called different things within the clouds as well. AWS and Google Cloud, they call it a virtual private cloud, so VPCs. Azure call it a virtual network or VNet. There are a number of different gateways. AWS has 3, and I'm going to cover them all. Azure has a virtual network gateway, and Google Cloud has a cloud router. Then further down the list, there are compute and object storage factored into the slide. Object storage, for example, it's S3 for AWS and it's blob storage for Azure. So there's a matrix of information there that's useful moving forward. So let's look into AWS. So first off, it has 3 connectivity models. There are 3 types of virtual interface, and there are 3 types of gateways related to this connectivity. So I'm going to kick off with the direct connectivity models. All of these things are related to each other, so there's going to be a bit of overlap between a few of the slides. So the first option that we will cover is the dedicated option. And this is where you typically are on the same data center as AWS, and this is available up to 100 gig. You can go into your AWS console and you can order a direct connect from AWS at speeds of 1, 10, or 100 gigabits per second. On a dedicated interface, you can have up to 50 virtual interfaces in a combination of public and private VIFs, but you can only have 1 transit VIF. So where you don't typically have very far to reach out to AWS, you can revision this connection just by getting a cross connect from your data center provider into an AWS connection, and you're up and running. The single transit VIF, though, on this offering often catches people out as they want to use multiple transit gateways, and this is becoming more prolific. So that is something to be very careful and to look out for. The next slide, or the next model, is a hosted connection. And this is how the Megaport partner model works. This is where your device will connect to a service provider like Megaport, anywhere globally potentially, and you can connect to any Megaport enabled data center around the world and use the Megaport global network of on-ramps to potentially connect to any AWS region. You can just go into your Megaport portal and provision this in minutes. And in this particular case, we're showing two customers going across the same on-ramp because this is how Megaport offers the service over its pre-built AWS on-ramps to multiple customers. With the hosted connection, there is no contention, and we dedicate bandwidth to your explicit service. The hosted connection allows you to configure one private VIF or one public VIF or one transit VIF. If you need another VIF, you create another hosted connection on the Megaport portal over the same on-ramp, and it will appear inside your AWS console. The data rate supported for these services is between 50 meg going up in steps to a full 10 gig. Okay, the third model is with AWS Direct Connect, is also a Megaport partner model, and this is called the hosted VIF. This is also available through the Megaport partner on-ramp, and it allows you to select speeds from 1 megabit per second all the way up to 5 gig in 1 meg increments. So you can turn it up and down, and it's highly flexible. You can scale it up and down as you want without affecting traffic other than the data rate. So it's very useful for certain types of customers who want that flexibility, and it also allows you to have flexibility in costs as well. One potential drawback with this particular model is there's no transit VIF capability. There's only private or public. However, it's highly flexible and Megaport absorbs the fee. It is a shared bandwidth on-ramp. However, Megaport sizes these on-ramps with AWS to ensure there's no issues between customer traffic impacting each other. And now we're going to talk about the virtual interfaces that run over these particular connections. So we have 3 virtual interfaces to cover. There's the private VIF, the public VIF, and the transit VIF. So let's take a look at the private VIF. We've got 2 different examples of that here. We've got a private VIF on the top diagram, and that's going directly into a VPC through a virtual private gateway, and that's a one-to-one relationship. We'll talk a little bit more about the gateway shortly. We've also got a private VIF going through a direct connect gateway, which will allow you to get to 10 VPCs with a single private VIF. MTU sizes are from 1500 to jumbo frames, and you're allowed to advertise up to 100 prefixes across AWS. But be careful, if you go over 100, then the eBGP session will be shut down automatically by AWS. So that's something to be careful of. The next service is a public VIF. So when you're using a public VIF, this allows you to connect to all AWS public IP addresses globally. So you will need to have a public routable IP address, and you will need to have a BGP session up between all your AWS services and a device. And you can advertise 1,000 prefixes across this link. This allows you access to publicly routable Amazon services in all AWS regions except China. And this gives you access to services like S3 or DynamoDB. And then finally, the final virtual interface is the transit VIF. You can provision the transit VIF at only 50 meg or greater. And this has recently changed from 1 gig minimum about 9 months ago. So it's become much more cost effective. You can connect this at 50 meg all the way up to 10 gig. You can do this on a dedicated or hosted connection, and then your transit VIF is connected to a direct connect gateway, which in turn is associated to the transit gateway. And this can connect to up to 5,000 VPCs. You still have the limit of 100 prefixes, and the MTU is still 1500 to jumbo frames. And now finally for AWS, let's look at the different types of gateway on offer. There are 3 of these: the virtual private gateway, the direct connect gateway, and the transit gateway. So the virtual private gateway, or VGW as it's known, is a redundant edge routing function that's attached to your VPC. It allows you to route traffic in and out of your VPC. And that's, as we described, as a one-to-one relationship in this case. In this example, your devices are connected via a Megaport, and let's say it's in a location enabled globally. You can then provision a service. In this case, it's a private VIF into a virtual private gateway, and this gives you full private connectivity to that one VPC. The next one is the Direct Connect gateway. So again, it's built on highly available resources. In this Megaport model here, you can connect up to 10 VPCs via a Direct Connect gateway. The flow of traffic from your VPCs will go through the Direct Connect gateway to the Megaport on-premise device. There is no traffic flow between VPCs. You can't get, with this particular product, you can't get one VPC to talk to another VPC through the Direct Connect gateway. If you need that, you can use VPC peering or a transit gateway. So onto that transit gateway. As I say, it's available at bandwidths from 50 meg or greater, and it's only available on a dedicated or Megaport hosted connection. In this example, again, we're showing it through a Megaport enabled data center, and you provision your transit VIF, attaching it to your Direct Connect gateway and associating it with a transit gateway, which then attaches to the VPC. These VPCs can be in different AWS regions, and you can attach up to 5,000 items per transit gateway, and the number of gateways you can have per region is 5, and the number of gateway attachments for the VPC is also 5. The maximum number of routes you can advertise is 10,000, and the number of transit gateways per Direct Connect gateway is 3. There are a lot of rules out there, and it's worth reading through the Direct Connect FAQs, so be careful. However, the transit gateways is very popular and very versatile and becoming increasingly used in AWS environments. So next, let's have a look at the Azure Express route. So we've got 3 things to look at here, but let's just have a look at a few concepts before we dive into that. So the concept of a VNet, we've already mentioned it's very similar to a VPC in the AWS and Google language. There is a virtual network gateway. So this is doing something in a similar function to the virtual private gateway in the AWS world. And the virtual network gateway is made up of multiple virtual machines behind the scenes. It's not something you can control, but it's something that Microsoft sets up in the background. But you do have to have a gateway subnet while you're creating a VNet. And then we've got the Microsoft Enterprise Edge routers. These are 2 highly available routers that you connect into when you're creating an Azure Express route. In the Azure Express Route Direct model, you can connect directly to them in a physical location. Azure will give you a primary and secondary interface when you provision your Express route on their portal, and you're expected to connect to both MSEE routers, router 1 and router 2 in this particular instance. You're then required to generate BGP sessions to those MSEEs from each of the customer devices. In this model, you can connect at 2 different data rates. You've got 10 gig or 100 gig. If you connect at the 10 gig model, you'll be given 2 interfaces with a total of 20 gig capacity, and the circuits that you run over them can be 1, 2, 5, and 10 gig increments. On the 100 gig connection, you have 2 interfaces with a total of 200 gig capacity, and you can have circuits of 5, 10, 40, and 100 gig. The MTU in both cases is 1500, and they both support Q&Q and .1Q VLAN tagging. The next Express route model is the Megaport partner model, and this is where your device will connect into service providers like Megaport. So you, as before with the AWS, you can connect into any Megaport data center around the world and use the Megaport network of on-ramps globally to potentially connect to any Azure region. You can go the same as before. You can go to the Megaport portal, you take a service key from the Azure portal, and you connect to us and provision with a number of minutes. So there's one thing to note about the Express routes is that you can start with a 50 meg connection, and then you can increase the Express route size to go up to 10 gig. incrementally, however many times you want. However, you cannot turn it down without recreating your service. So it's something to bear in mind when you create these services, that you can only go up, you can't go down. This also supports Q-in-Q and .1Q VLAN tagging. Okay, so let's have a look at the different peering types. There are two different peering types on top of Azure. There are private and public, as well as a quick look at the local, standard, and premium SKUs. So the first thing is private peering. You'll need to have 2 BGP sessions up if you want the Microsoft SLA. You can have them in active or active standby mode. And then what's called a standard SKU. And this connects you into a single geopolitical region. And this allows you to access 10 VNets in that geopolitical region from your express route peer location. So what does this mean? So Microsoft has 18 connections peering in Europe, and this is where the customers can connect to them over partner or dedicated connections. If you go to just one of those, and let's say you're connecting into an express route location in Amsterdam, you can get VNets into any of the 12 regions in Europe with a standard SKU. And likewise, they have similar SKUs in the US region and Asia Pac region. So that's pretty powerful, and you can reach out to those regions without any extra expense. So it's a really, really nice feature. If you want to reach outside that geopolitical region, then you need to go for a premium SKU, which supports global connectivity. So back to that same example, you reach out from your Amsterdam location, turn on a premium SKU, and you can have a VNet to any region in the world. However, this is always comes at a higher cost of a standard SKU in terms of costs. You can support up to 4,000 prefixes, advertisements on the standard SKU, and you can support up to 10,000 on the premium SKU. And then finally, there's the local SKU, which is available in both the direct and Megaport service provider models. So to make this more clear, the Express Route Local Service is a service that's available to you when you are connecting to an Express Route Interconnect location adjacent to the workloads or VNets where your workloads are residing. If you do a lot of egress data from Microsoft and you connect at a higher than 1 gig speed, using a local SKU within a region means you do not pay egress charges. So one advantage to note here is Megaport can get you to that local SKU on-ramp location via its private global backbone and appear locally to regional VNets or workloads. So taking advantage of that no egress charges. So it's a very powerful tool and a very powerful way of delivering services at very low cost. So now on to Microsoft, or what was public peering. This is where you want to access Azure public services or Office 365. A word to the wise. To achieve this, you need to go through a review permission process with Microsoft. So what does this service look like? So it's very similar in setup to what we looked at before with private peering. A customer device in this example goes through 2 Megaports, two diverse on-ramps, both with a BGP session to a respective MSE router. Once you have permission, you can set up route filters that are mandatory and receive routes from Microsoft peering. Using BGP communities will allow you access to services in the Microsoft public domain, such as Active Directory, blob storage, and archive storage. Microsoft support using both public and private and Microsoft peerings at the same time on an single express route service. This is enabled by using Q-in-Q, and it will travel transparently over either a dedicated connection or the Megaport partner network into your device. If you want to run a single service, such as a private peer or Microsoft peer, then .1Q can be utilized. So your device will need to support Q-in-Q or .1Q to achieve whichever outcome that you're looking for. Okay, and then finally, we're on to Google Cloud Interconnect. So there are 2 models here, but let's just get a few terms out the way before we move on. So the first one is Cloud Router. So this is this dynamically exchange routes between your VPCs in the Google Cloud and your on-premise router. Again, a BGP session is expected between Google Cloud and your device, and the cloud router itself is allocated or lives inside a single VPC. It's a little bit different rather than being associated. And then the interconnect attachments are connected. So these are logical connections between your on-prem network and a single region in your VPC network. It's worth mentioning that Google does not offer a public peering option. If you want public services like cloud storage, you would need to use the Google Private Service Connect, or use the internet or an internet exchange. Above in this diagram is the dedicator offering. So for Google, you have to have a 10 gig or 100 gig service into Google, and you can provision the connection into different zones. And that is a requirement if you want an SLA from Google Cloud. You'll also need to turn on LACP and multi-hop, even if you are using a single circuit. And the presentation is .1Q. Okay, moving on to the partner interconnect. In this case, we're showing you just a single connection coming through a partner in the Megaport network. We've already completed all the connectivity as we built a large number of on-ramps throughout the world. In this case, we're showing you it into a single zone. It's recommended to connect to a second zone, especially if you want an SLA. With the dedicated or partner interconnect model, as stated, the logical attachments are between your network and a single region inside your VPC network. If you're a dedicated customer, then you provision the attachments on the port that you procured from Google. But if you're going through a partner like Megaport, you provision a partner interconnect attachment using the Megaport and Google portals. The VLAN can connect into any metro edge access location within the same geopolitical region, because Google does not offer a global solution. But there are techniques for connecting different regions together. So this is something to bear in mind when you're designing Google infrastructure. As an example, Megaport can backhaul your traffic to those Google Metro Edge access locations over its own backbone network to help resolve some of these issues. So finally, thank you. But it's also worth mentioning that Megaport can provide all these access to all these cloud services and many more over the same physical Megaport. Megaport can provide services such as Megaport Cloud Router and Megaport Virtual Edge to enable native cloud-to-cloud interworking, so you don't require a data center, and allow direct communication between different cloud providers. And these will be covered in different soundbite sessions. So this ends the high-level session of the multi-cloud connectivity options. For further information, please contact your Megaport account teams, and thank you for your time.